This is a heat pump wiring diagram, and by the end of this video, you will read one at a glance. Look at the low voltage terminal block, R, C, Y, G, O or B, and W2. Watch me trace the very first wire, R, the 24-volt power, straight off the control transformer. Now, if you have read a regular air conditioner or furnace diagram before, some of these letters look familiar. But a heat pump adds terminals a standard system simply does not have, and those are exactly what we will decode. This is how to read a heat pump wiring diagram, aimed at the low voltage control side that actually trips people up. So what makes a heat pump diagram different? One idea. A heat pump both heats and cools with a single refrigerant circuit. There is no separate furnace. Instead, it runs the compressor and simply reverses the flow to switch between heating and cooling. And that one trick shows up all over the wiring. A plain air conditioner gives you R, C, W, Y, and G, power, common, heat, cooling, and fan. A heat pump keeps those, then adds three things. A reversing valve terminal, called O or B, to flip between heat and cool. Auxiliary and emergency heat, W2 and E, for backup. And a defrost board out at the unit. Learn those extras, and the whole print opens up. Everything on the control side references two wires, so start there. A small transformer steps the line voltage, 240 or 120, down to 24 volts. That gives you R, the 24-volt hot, and C, the common return. Every call the thermostat makes is really just are being connected to one more terminal. And here is the single most important habit for reading any heat pump print. Separate the two voltage worlds. There is the line voltage side, the fat wires feeding the compressor and the heat strips with real, dangerous power. And there is the low voltage side, the thin 24-volt control wires running out to your thermostat. Trace them separately, and nothing on the page can confuse you. Quick note, every diagram you're seeing is drawn in a free editor that runs right in your browser, CircuitDiagramMaker app. No install, no sign up. Open in a second tab, drop in a terminal block, and trace along with me. The link is in the description below. Now the terminal that defines a heat pump, O or B, the reversing valve. Inside the outdoor unit sits a valve with an electric solenoid coil that physically flips the refrigerant's direction. The O or B wire is what energizes that coil. Here is the catch that trips everyone up. Brands disagree on when it is energized. On most systems, the O terminal is energized in cooling. On a few, Rheem and Ruud are the classic example. The B terminal is energized in heating instead. So how do you tell what you have? Follow the wire. If it lands on a terminal marked O, the valve energizes for cool. If it lands on B, it energizes for heat. Your thermostat has a matching O/B setting. Get it wrong, and the system blows cold when you call for heat. Next is Y, the compressor. Trace Y, and it runs to a contactor in the outdoor unit. A contactor is just a heavy-duty relay. The 24-volt Y signal energizes a small coil. That coil pulls in big line voltage contacts, and the compressor and outdoor fan get their power. This is the low voltage controls high voltage idea, same as any air conditioner. But notice something a furnace diagram never shows. On a heat pump, Y runs the compressor in both heating and cooling. Is the reversing valve, that O or B wire, that decides which way the heat flows. Y makes it run, O or B aims it. Then there is G, the fan or indoor blower. Trace G and it energizes the blower relay or the fan control board. On the indoor air handler, pushing conditioned air through your ducts. On the diagram, it is usually its own tidy branch off the terminal block. Nothing heat pump specific here. It is the same G you would find on an air conditioner. But you'll want to spot it, because in a moment the defrost cycle is going to borrow control of these same outputs. Here is another heat pump only section, auxiliary and emergency heat. A heat pump gets less efficient the colder it is outside, and on a really cold day, it simply cannot keep up. So the system adds backup electric resistance heat strips, drawn as those zigzag resistor symbols on the line voltage side. Two terminals control them. W2 is auxiliary heat. It kicks in automatically to help the compressor when it is falling behind. E is emergency heat. You switch to it manually, and it runs the strips alone with the compressor off, useful if the compressor ever fails. Both energize a sequencer or a relay that switches the high current heat strips on. If you see W2 or E on the block, you're definitely reading a heat pump. Now, the part that is truly unique to heat pumps, the defrost board. In heating mode, the outdoor coil runs cold, and frost builds up on it. To melt that ice, the defrost board takes over. Periodically, it flips the reversing valve back to cooling for a few minutes, so hot refrigerant flows out to the coil and melts the frost. At the same time, it shuts off the outdoor fan and turns on your auxiliary heat, so you're not blowing cold air indoors. On the diagram, the defrost board sits between the low-voltage terminals and the outputs, tapping into Y, the reversing valve, the outdoor fan, and W2. When a heat pump briefly steams outside in winter, that is the defrost cycle you just read on the page. Let's put it all together and trace two calls. A cooling call. The thermostat closes R to Y and R to G, and on an O system, R to O. Y pulls in the contactor, O energizes the reversing valve for cool, G runs the blower. Cold air. Now, a heating call. R to Y and R to G again, but O is off, so the valve rests in its heating position. If it gets cold enough, R to W2 brings the heat strips in to help. And every so often, the defrost board interrupts to clear the coil. That is the whole logic: thermostat to terminal block to contactor, reversing valve, and defrost board. Low voltage commanding high voltage every single time. So that is how to read a heat pump wiring diagram. Start at the transformer, R and C. Then the extras that make it a heat pump. O or B for the reversing valve, Y for the compressor that runs in both modes, G for the blower, W2, and E for backup heat, and a defrost board that borrows them all in winter. Keep the line voltage and low voltage worlds separate, and follow each wire from the thermostat out to its coil. Want to practice? Open the free editor, drop in a terminal block, and trace a call yourself. The link is below. Subscribe for a new diagram explained every week, and I will see you in the next one.